Hello and welcome to the fifth lesson in the second part of statistics in Year 11 Standard Maths. Today we are going to be looking at how you could describe some distributions. We'll be looking at frequency histograms, frequency polygons to start with, which we've already taught you to draw back in the first unit of statistics. And then after we've done a few terms here, we'll look at frequency histograms and box and whisker plots. Box and whisker plots you will do in Year 10, so hopefully you remember those. We'll actually come to parallel box and whisker plots later on in this unit, so don't worry too much if you've forgotten about them. But now it's just some terms, some language that helps us describe what the different shapes could look like. So the first thing we can consider when we're looking at a frequency histogram, a frequency polygon, is the smoothness of the curve. If a curve is smooth, what does it have? Well, it'll have no breaks, no gaps in the curve. Same thing. It will also have no jagged sections. So jagged sections where it goes up and down really quickly, sort of spiky bits, all those kind of ideas. A good example of that would be if you see the business news, if you look at the share price index of a business over time, you tend to find that those go up and down very quickly, lots of sharp highs and lows, and it's not very smooth at all. So if a graph was smooth, what would it look like for a frequency polygon? Well, it would look something like that. As you can see, it's a nice curve. There are no spikes up and down or anything like that. You tend to get smoother curves the more pieces of data you've got, because then you tend to have more of a chance for every possible height, score, weight, whatever you're measuring to be represented somewhere. So that is the first one, just whether it's smooth or not. The last three are just terms about how many modes a graph has got. Now, when you're analysing data from lists or frequency tables, modes have got very specific definitions. It is the piece of data with the highest frequency. It could be more than one number, and they would have to have the same frequency. It's not quite the same when we're looking at the shape of distributions. So first off, the first option is that the graph is unimodal. So if the data has one mode, or a peak when we look at the graph is how we could think about it, we describe the shape of the distribution as unimodal. So I'll try and do it slightly differently to the one above. It could look something like that. One peak right at the start here. So there's just one mode. We would read it off on the horizontal axis down the bottom. So uni means one, so unimodal, one mode. Think of a unicycle, it's got one wheel. The second thing from that then, if we go up, is that it's bimodal. So bicycle has got two wheels, so a bimodal shape has got two modes or peaks. Now, like I said, slight small change in the definition compared to the mode of a set of data, in that the two modes, the two peaks, do not have to get to the same height on the distribution. So we could have them like this. So you can see if we were looking for the statistical definition of the mode, this first peak would be the definite mode, because it's the point on the graph, it's the data that has got the highest frequency. There's no higher point anywhere along the curve. However, we describe it still as bimodal because there's this second peak over here on the right, where even though this number has got a lower frequency than the other one, in this sort of local area, so the sort of area of the graph between here and here, it's a peak compared to what's surrounding it. So overall, we would still call that bimodal. Similarly, the last thing then, if we keep going up from 1 to 2, is anything more than 2. So we would just call that multimodal. modal, and it just means that it has got multiple peaks. To save space, I'm just going to draw a quick example of one with 3, but it could have 4, 5, as many different modes or peaks as you wanted. Once again, they don't all have to be the same height. You can check that this first one is a different height to this second one, is a different height to the third one, but we would call it a multimodal distribution, even though there's only one mode, which is the furthest one on the right, because that's the highest frequency. Okay, so on the next page, the last thing that we are going to look at is the things that apply to frequency histograms, frequency polygons, and blocks and whisker plots. The first thing we are going to consider really is a symmetrical graph. So the slide is called symmetry or skewness. It's going to be one of these two things. Data is either symmetrical or it's skewed. So if the shape is symmetrical, the idea is that if you kind of folded the frequency distribution, the frequency polygon in half around a sort of vertical line, then it would, one half would match to the other one. So it is the same either side of a vertical line. On a frequency polygon, what would that look like? It would look something like this. Do my best to make it look symmetrical. Not perfect, but hopefully you can get the idea that from this middle section to the left and to the right, they're supposed to match up exactly. Perhaps the left could go down a little bit to there, but that's the basic idea. We'll exaggerate the other ones. On a box and whisker plot, well, the vertical line is kind of already there for us, actually. It's quite helpful. It would be the median. So either side of the median, the box would be of equal length. And then the two whiskers that come out from the box and whisker plot would also be the same length. So a symmetrical box and whisker plot would have that rough shape. So the second and third option are that it's not symmetrical in some way and that it's actually skewed somehow. The first option I'm going to quickly go over is positive skew. So you may actually remember this from year 10. We do it describing the shape of distributions. Positive skew means that the data is mostly on the left for a frequency polygon or a frequency histogram. What you would kind of see is what's called a tail frequently, a tail on the right side. So as the numbers get bigger, there's the tail. So where the tail is determines whether it's positive or negative skew. So let's exaggerate this quite a bit. For a frequency polygon, we would get data that looks something like that. For a box and whisker plot, the data is bunched towards the left. So if we had a box over here, the median would be closer to the left-hand side of the box. And then overall, the box would be to the left of the area between the two endpoints, the two tails. So the box has moved to the left, and the median within the box is on the left as well. The opposite to positive is negative. So the opposite to positive skew is negative skew. Because it's the opposite, the data is not on the left, the data is mostly on the right. Not all of it, but most of it is over there. So most of the data has got high values within the group. So that means that the tail is on the left. So for a frequency polygon, what does it look like? It looks like a long tail here, and then we come up and all the data is kind of concentrated on the right. For the box and whisker section, the box is concentrated towards the right-hand side between the box and the two whiskers, and the median is pushed towards the right-hand side of the box as well. Okay, so that's it. That is how we describe distributions. You need to complete exercise 10D to finish this. Mostly you just need to describe distributions that are already there, but to help revise, there's also a couple of questions where you need to plot some data and then describe its distribution afterwards. So a good opportunity to revise the first part of statistics. As always, come to the lesson prepared with any questions for your teacher. They'll let you know which questions are perhaps best for you to do, but you can ask them for help with whatever you need. Okay, thanks.